Alright, our first speaker is none other than Batist Leman, CEO and co-founder of Azumuta. And those that speak Dutch already know where this is going. It's for the English-speaking folks among us, it means that it works that way. Roughly translated. Azumuta provides people with a platform to manage their work instructions. Something very vital, obviously. And they will give us a talk on the importance of data capture and the importance of the ease of data capture with a focus on human data, if I get that right. Give it up for Batist Leman. The floor is all yours.
Thank you. Hi, thank you. Good evening, I'm Batist from Azumuta. Today I will be talking a little bit about how we see data ops in Industry 4.0 for the humans. So Azumuta is a platform that supports operators in factories, and so that's the point which I will be talking about today. So to give you a little bit of an overview of what we are doing with Azumuta, so we have several modules on our Azumuta platform. We have a module around work instructions. So this is explaining to an operator what he needs to do and how he needs to do it. And we tailor these work instructions to the data that's coming from the ERP system, so that the configuration of the product is clear for the operator. For example, there is an option to mount a towing hook on one order and not on the other order. And there you can show the operator that there he needs to install the towing hook, and on the other order he doesn't. So custom work instructions tailored to the specifications, but also tailored to the operator. So an experienced operator has a little info, and a new operator has a lot of info, so that it's not uncomfortable to have too much info, and also supportive for new people. Then we have a module around audits, and audits is basically checklists that they are doing right now. In a lot of factories, they still do this on paper, and we have a digital way of doing this. We have a training and competency management module, which means that you can track the competencies of your operators in your factories, and also map where the knowledge gap is, and who you should train for what work instruction and what knowledge that you should capture in your factory. For example, if an experienced, if there is only one operator for a certain machine that knows how to do things, then it's important that you capture this information so that if the operator leaves, that the data or the knowledge is not lost with that operator. And then finally, we have two modules left. So the product checks is product quality assurance. During these work instructions, we can ask the operator questions, and then we can assure the quality for each step during the process. And then the last module is the shop floor feedback, where we make two-way communication. So right now, in a lot of factories, it's one-way communication. So they tell the operator what to do, and the operator executes. But there is little possibility to give feedback. We make it very easy for the operator to notify something, make a remark, say that the quality is not good, that there is an issue with something, and that's the shop floor feedback module. So today I will be zooming in on each module that we have, and then see from a data ops perspective what you can do there practically. An important note is that we have two kinds of interfaces. So we have an admin interface, which is meant for the administrator that configures work instructions, that manages the input from the ERP system, that monitors, that makes analysis from the data that is captured. And then we have the operator interface, which is very easy, very simple. You shouldn't need an explanation on how to use it. It is completely self-explanatory. And it's also multi-platform, so it doesn't matter where you are getting your input from. Very visually, how does it look? So we have tablet factories where they use tablets. So mostly, if the operator is mobile and is moving around through the factory with his product that is assembling, for example, he uses a tablet. Also, in the case of audits, then a tablet or a mobile phone is mostly used. We have mixed setups where there is a mobile computer on a little bench that they roll around. And then we also have completely fixed setups where they scan the order and then they see it on screen. Azumuta is a SaaS platform, so it's not something that you buy and install. No, it's just running in the cloud, and you consume it to the amount of users that are needing the product. So first of all, the work instructions through the glasses of the DataOps view. There we see the data flow going from work instruction creation, so it needs to be easy to create a work instruction. Then you have the tailoring to the configuration and to the human. And then the data flow from the ERP system to Azumuta. And then we have the data analysis and reporting. And sometimes there is a step back to the ERP system so that there is a real-time synchronization. And it's important to set this up as automatic as you can, because now in many manufacturing plants, we see that this is a completely manual process. So they stop from making a work instruction, then it's just on paper in a Word document. It's very hard to do something with it because it's data. Yes, it's in a Word document, and it's sometimes digital because they make a PDF. But that's not really what digital is about, of course. No, it needs to be something fluent, something structured, something that is consumable as metadata, so you can apply layers on top of it. So, for example, tailoring the configuration, it's taking a configuration from the ERP system and tailoring the metadata from these work instructions to this configuration. And then you have something that is connected and flows automatically and in one way and the other way. Same with the data flow from the ERP system. So now in many manufacturing companies, they still print the product order. The printed product order goes into the factory, then they do everything, and then finally it comes out, and then you see, oh, no, it's broken, or if the customer asks what's the status of my order, they don't know. They need to go look physically in the manufacturing plant to see what the status is. And so it's very important from a DataOps perspective that you can automate this, that you couple these flows to each other, that it's suddenly visible in a digital way. A little bit of visuals on how the platform works. So we have, this is the browser where you can edit the work instructions very easily. You can annotate these images, you can use images, videos, PDFs, you can attach everything as metadata, as mentioned, to this work instruction. You can also use tags like this. So in this case, these are variants, and you mark certain steps as being a variant. So it's nothing more as applying labels to each step. So based on these labels, you can do multiple modifications to your raw data or filterings, for example. So this is then coupled. So here you have a list of orders, and you can see the variants. So in a lot of cases, they have a lot of variants for each product. So there you can just where previously they had multiple Word documents that need to be synced in parallel for each type of a product that they were making. Now you can just do it dynamically, and the amount of possibilities is of course endless because you have multiple variants. Each combination, it's thousands and thousands of possible combinations, and by doing this digitally, it is easier than before. You can also do a time analysis. So an operator is following the work instruction, and he's moving through the work instruction in a dynamic way. And instead of doing a time analysis once in a while, what was previously the case, so they did, for example, stopwatch method, is to see how long, what is the duration of each step in the work instruction. They were doing it with the stopwatch, just like once a week to check it. And now you can do it continuously because that's structured through your data ops concept, where you track everything continuously, and all these data streams are connected. So this is a result from a few days of producing. You can see exactly how long it took to make such an order. And this makes your prediction, of course, much more reliable. You can see the exact amount of time for each product, and also for each operator, of course. And there sometimes it can be tricky. You need to be careful that you're not over monitoring the operator, that is not having a big brother feeling, as certainly not the intention, but you need to be careful there. There is a thin line between being big brother and trying to help your operators. Then you have the audits, and from a data ops perspective, so the first step is that you define your check.
No,
Okay. Okay. I have 20 minutes. So there you have your check definition. So it needs to be very easy to configure your quality requirements. It needs to be very easy to change them if necessary. And you have the recurring data capture. So you have to install a system that you say, okay, I want to perform an audit on this workstation, and then the next week I want to perform it again, and the next week I want to perform it again. And you need to do this not only for one workstation, but for all your workstations in your factory, not only the workstations, also, for example, measurement units or welding stations. You need to perform audits of all these different things. And it's right now it's also mostly on paper. So you need a solid system that monitors that you are doing everything and following up with it. It needs to be very low friction for an operator to fill it in, and also to report it, because in a lot of factories they do this and they synchronize it by typing the papers into Excel and then sending the Excel through email. And then, So if you connect all these steps, what you get is something like this. So you have your checks, very easy to configure in a user interface, where you can say, I want to do, for example, on a 5S audit, you want to check if your workstation is clean, and you want to measure this with a score, for example. And then finally, you want also that the operator is taking a picture of the workstation. So it's not only a score, it's not something that is abstract only. You also want to prove it with the picture that the workstation is clean. So the complete factory is separated in a tree. So you have the zones in the factory, then workstations in the factory. So you have an overview of your complete factory, and then for each thing you want to perform an audit on, and each of those things has a timeline. And on this timeline, you can see the status of all the audits that you are performing. You can follow up with if you are actually doing them. You can see who needs to do them, were they done or not, then the status will change. Then the operator gets them in a list, he needs to do them, the operator follows them on a tablet or mobile phone, and then the data is synced and you get a report, and you can also make dashboards out of it. So you can track your progress over time and see if your audits are improving or not. It's also important that this data is available to the customers, to the factories, that they can do whatever they want with it. So you can couple, for example, Power BI systems to it, that they can do their own analysis. Because if you build a platform, you don't need to want to do everything for them. If you give them the data, they will do their own analysis and you can play around with it. And then we have the product checks data ops. So it connects to these work instructions where you specify your quality requirements. Then you have the ERP synchronization again, as mentioned. There also it needs to be low friction. And the low friction is also, if you show too much data, it can be a high friction. So if you ask too many things, it can be high friction. So you need to find a good balance on not asking too much input from your operators, not showing too much visualizations and information. And yeah, so that's also something to, if you use a system like this or build your own system, that you need to be careful about, that you find this right balance. And there again, it's just the same as in the audits. So you can choose your checks. For example, you need to measure tolerance, and you can say this tolerance needs to be between this or that. And if it's out of tolerance, you need to follow up with some extra steps. So all these flows, you can build it in automatically in a very flexible way, so that the operators really help through this system automatically. Then again, it synchronizes with the ERP system. The operator fills it in. You can keep track of the orders and see their status in real time. So, for example, you have several steps that need to be done for making a product. You can exactly see where they are in the steps. So, for example, here I can see that station 1 is done, station 2 is done, and now they are still working with the cabine product. And here it's blurred, of course, but you can also see how many hours that you're already working on it. So you can really see in real time that this is going. Then also here we have the reports, and you can see what quality checks that they filled in. For example, in the automotive industry, they need to follow up with the torque. The torque of each screw in the car, it needs to be monitored and locked. And there you can get a final report of all the torque values that are connected by the operator in your car. Yeah. And that's perhaps a bit too technical here for this conversation, I don't know. But there we also have a shop floor API. So we have an API for managing the ERP system and for getting the data out of Azumuta, so you can do your own analysis. But we also have a shop floor API where we can connect to the tools that the operator is using. For example, the torque tool, typically you need to send the command to the torque tool that it needs to set that wheel for this work instruction on torque tool 16 Newton meters, and then the operator screws it. And then there is an exact amount of Newton meters that is practically set on the wheel, and then it needs to be locked in your system. And this can be done automatically with the shop floor API. So also from a data ops perspective, it's important that you make something that is not managed by one player. You have an open system that you can connect multiple things and multiple ways to each other. And then there you can also have a report. In this case, this is Provan. They are making medical benches, and it's very important that they keep track of everything. For example, if they take a motor, they need to log from which batch the motor is, and they, for medical reasons, they need a very detailed report of each product that they are making. And where previously it was a lot of manual work, and it was not really sure if it was really correct. Now it's automatically, it's less work, and it's absolutely correct, you can't make any mistakes. And then finally, not finally, but the training and competency management module. 20 minutes. Yeah. Well, it will speed up. So perhaps this is also a bit less relevant for this talk. But we have a training and competency management module where you can keep track of all the competencies of the operators. It's very similar to the audits, so you have a list of tasks, and the operator follows the work instruction and the training on his tablet, and then it's synchronized in a view like this, where you can see all the operators and their skill level for each work instruction. But here we are doing some research projects to see if we can automate this. But it's mostly manual decision of the trainer. So the trainer decides, okay, this operator has level 3, for example, for a certain work instruction. And also there, the operator can see what steps are new compared to the previous work instruction automatically. Because this is stored as metadata, you can just make a tree comparison from those two trees. And then finally, the shop floor feedback. So there, it's very easy for an operator to make a remark of something, so that you can capture the human things. And the operator says, okay, it has to do with the quality of a piece, or with the safety of a person, or I have an improvement idea to make something better. It's very easy to make a suggestion, and then it's being tracked in Kanban boards, or in this case a PDCA board, where you can follow up with each issue. We see that they place this on TVs in the production hall, so that an operator can see, oh, okay, I made a remark, and it's actually being followed up, and I can see the status of my remark live. Where previously there was like this small ID box, and then it was like a black hole, you put something in and you see it again. And in this way it's far more engaging for the operators and motivating for the operators to actually make a suggestion to make things better. Okay, so this was a little bit of a summary how we at Azumuta look at data ops in our platform, and how we think that the Industry 4.0 can be done with humans in factories. Okay, thank you. Any questions?
Yeah, I've got one. You've mentioned capturing data on humans and not wanting to become Big Brother.
Yeah.
Where do you draw the line?
It depends on the factory.
Okay.
Yeah, it depends on the factory. We see that in the smaller factories, where the community is smaller, there is more trust, and they go a little bit further. While in the larger companies, there is more, sometimes, not always, but sometimes a bit more distrust between parties, and then we see that it's more difficult and it needs to be better aligned and more strict. Yeah.
You've made a remark that you, or at least that your platform allows you to switch from measuring people's performance with a stopwatch once a week to actually managing it in real time.
Mm-hmm.
Do you have any data on how this particular data improves supply chain management? Like, does it actually impact lead times by that much, or not at all?
We don't have data about that. No, we're not monitoring. The companies are using it themselves, but I'm not sure if they can make it more strict than before, because that's most of the time the goal. Maybe we don't have data about it. Was that a question?
I had a question about how do you implement the system, because when you want to use it, there seems to be a lot of steps that have to be taken to implement it in your company.
Well, no, actually, we can implement a system like this in a few weeks, and it's completely set up. Because most of the time they start with some simple checklist that is now on paper. You can just import it in Azumuta, and you can start immediately. So no, it's not actually that hard to set it up. No.
Can the system cope with dynamic work instructions? Work instructions where there's always small variations, or do you need to know the whole breadth of the work instructions beforehand?
I'm not sure what her...
Well, imagine you have an operator working on a line. He gets his instructions from SAP, whatever.
Yeah.
And then he performs those instructions.
Yeah.
Then you get other instructions that are brand new. How does the system cope with that? Is it like the guy I saw with the laptop that needs to change those instructions so that the operator receives the right?
Yeah. So
how dynamic is it? How flexible is it? How fast do you?
Yeah. Well, in most factories, if for example the customer makes a remark, and then they need to change something in the process to make, for example, an extra quality assurance step, for example, there is also always a button and it's loose. Then they will change the work instructions to make sure that the button is not loose. They will add some extra steps to correct for this. And this is done in hours, so it can really be very quickly. And it's also important to note that as soon as a product order is started, the versions of the work instructions are fixed. So each work instruction and each step of a work instruction has its own version management. And this means that first of all, if you make a training, you can say I have a training for that version, and then there is a new version, or you are 3 versions ahead, and then you can compare those through the versioning system actually. And so when an order is started, the version is clicked, and the order will be made with those versions. If there are changes to the work instruction, they will only be applied on the next orders to make sure that, for example, if you drag one instruction to another step in your process, you need to make sure that you are not dragging it in real time and forgetting the step completely because you dragged it just before the date that you are at. So you need to be careful there. If you want, you can manually upgrade them and you can work like this. Yeah. But you need to be careful if you do the manual upgrades. Yeah.
When an operator actually logs a complaint or a remark or whatever, is there an option to integrate it back into a system like SAP, for instance, so that real-time planning can change based on this machine no longer works?
Yeah, it can be done. So we have an API for basically everything. So we are also internally consuming our own API. But for example, if you log something, you can send a trigger automatically to another system to notify that there is a problem. Yeah, it should be as much of a problem.
Follow-up question on the Big Brother question, actually. You were talking, it kind of depends on the company, how far you will go.
Yeah.
How does this work GDPR-wise? Do you have to have consent of the people using this?
So we are a data processor, so we are assuming that the companies have contracts with their employees. But most of the time, a lot of those things that we do digitally, it's already the case, but on paper. For example, if an operator makes a remark, yes, I did this quality assurance check, and he signs off, then you also have proof that the operator signed off. So it's not that much of a difference in most cases.
Okay, thanks.
Any other questions? Yeah.
Yes, HoloLens. Do you have any plans to work with that?
Yeah. We have multiple new technologies that we are experimenting with. Some of those technologies are like glasses, like Google Glass. Basically, it's just a small screen. It's not very different. It's just placing your mobile phone like this. Then we have the HoloLens, where you can have augmented reality. We are doing experiments, but not ourselves, but with a partner, of doing the trainings completely in VR, and also projecting them on the table, and then showing like a video there with the projector, and doing checks with camera optics and so on. But those are, in a lot of factories, everything is still on paper. So the thing we say that is, first, make sure that you do the basics digitally, and then think about VR and AR glasses, and so you can attract people with things like VR, but so you don't need to attract them only. You also need to be real and implement something. So,
Yeah, maybe a small question, but you say you store everything in the cloud. That's no problem for your customers?
It is. So data security is a concern, and so we are already doing long-time efforts for data security. And we are also ISO 27001 and SOC 2 compliance. So that's an important thing for industry customers, that you are compliant with high level of security. And there you are in the constant loop of doing pen tests and automated tests and all kinds of policies. So it's a lot of work, but I think it's worth it. Just So some of the policies are perhaps a little bit overkill, but a lot of them aren't, and it's very good that you have them. For example, disaster recovery plans. You really need to have that, and it's something that if you don't get certified, it's something that you install, and it's great. So it's really important to have them. Any other questions? No?
Okay.
Then I will hand back.